we are going to get introduced to piecewise notation. Now, every time you have an absolute value graph, you could write it often in two pieces, sometimes three pieces. So I'm going to show you what that looks like. First of all, in A, I'm going to quickly graph for you 2x minus 1. Okay, 2x minus 1 would have a y-intercept at minus 1, right? And a slope of 2. And a y-intercept at, plug in 0, it'd have a y-intercept, an x-intercept at 0, 1/2, a y-intercept at 1, and I'm just going to draw the inside with a dotted line, has a slope of 2, and then the absolute value part I'm going to graph in green. You see that this part would stay the same from the dotted line, but the other part would get reflected up. And what we have is like two lines glued together. Can you see that an absolute value graph is like two straight lines glued together? But we only have part of the line on the right and part of the line on the left. In mathematics, there's a way to write this. We would write it like this, and this is called piecewise notation. And in order to really see it, I'm going to color code things. I'm going to color code this half in blue, the other half in green. So piecewise notation looks like this. You write y equals, and then you do a fancy squiggle bracket because you are going to write an equation for the blue line and an equation for the green line. I'll start with the green one. What's the slope of that line? Negative 2. What's the y-intercept of that line?
1.
Positive 1. Can you, green, I said I'd start with green. Can you see that the green line is negative 2x plus 1? But if I did negative 2x plus 1, it would keep on going. Oh, thank you guys for noticing I made a mistake and being so kind and not say anything. You see I labeled that point wrong? What do you label first, x or y? This should be 1/2 comma 0 instead of 0 comma 1/2, right? And you all noticed that, and we're all so kind.
Okay, throwing a corner for the
Okay.
You are just covering it. So
Oh, wow.
We didn't want to interrupt you. Thank you for help us doing our best.
And what we do in piecewise notation is it's called piecewise because you don't have the whole green graph. You just have a piece of it. Which piece of the green graph do we have? We put a comma and we say we have the piece when x is less than or equal to 1/2. We have this part for the green one. Does that make sense? The blue one you already knew was 2x plus 1. And you have that piece when x is bigger than 1/2.
Does it matter which one has
The equal sign to it? No, you can't put the equal sign on both of them. You're supposed to only include the half on one of them.
Yeah.
Later on in calculus, because sometimes the pieces aren't joined.
That's fine.
Okay? But it doesn't matter which one has the equal sign. In this case particularly, because they share that point. Okay, part B. If we drew the picture out, we've got the absolute value of negative x squared. I'm going to just write it out. Absolute value of negative x squared minus 3x. If you graph the inside, Do you see this parabola that opens down? If you going to just grab the inside in blue, I'm going to factor out a negative x. Can you see that if you write this in factored form, that would be helpful in finding your x-intercepts. There's going to be an x-intercept at 0 and an x-intercept at -3. Which way does this open? Opens down. So the vertex is going to be right here somewhere at 1/2. Yeah, I don't know exactly where I'm going to estimate it. I know that I have 0, 0. I know that I have -3, 0. And if I wanted to, I could plug in -1.5 and solve for y. I don't feel like doing that right now. But I could.
Me neither.
Perfect. Can you see that the absolute value graph, this section, which I'm now going to sort of erase a little bit. I'll just keep it, I'll keep this as a dotted line. Do you see that with the absolute value, that section would get flipped up? Okay. Piecewise notation. Y equals. Sometimes it's easy to start with the part that didn't change, that didn't get flipped up, right? The blue part, which I'll write in blue here, was -x² minus 3x. The inside is what we graphed first. When do we have that blue part? Between -3 and 0 now. What is the equation of the green part? And the easiest way to write the equation of the green part is to take the equation of the blue part and put a negative in front. Does it make sense that if all your y values were negative and you wanted to make them positive, one way that you can make a negative number positive is by multiplying by a negative? Algebraically, we could take the original equation, put it in brackets, and say if these are negative numbers, because I flipped them up, all I would have to do is put a negative in front, making them positive. I could simplify that now. Do you see that that would become x² plus 3x? And when do we have the green part? We have the green part when x was less than -3 or when x was bigger than 0. And this is the piecewise notation for the parabola. Technically, if you flip the whole parabola, that's x² plus 3x, the green graph. But we're only flipping the parts that are negative, up, and above. Okay. Can circle questions 8, 9, and 13.